actually get into the quadratic formula, we're going to learn something called the discriminant. And the discriminant is a number. When you have a quadratic in standard form, it's a value. It's just a number. It has a formula, and that formula is b squared minus 4ac. And the purpose of the discriminant is to tell us how many and what kind of x-intercepts a quadratic has. So if you are looking at an equation in standard form, a quadratic equation, if you use this formula, you can tell, is it going to have one x-intercept? Is it going to have two? Is it going to have no x-intercepts? And so the way you tell that is if you use the formula and the answer that you get, if it is a positive number and it's a perfect square, then you will have two rational x-intercepts. What does the word rational mean? Anybody know?
Isn't it like numbers that
Yeah, kinda. So technically a decimal can be rational. It's a number that is a whole number, or it can be written as a fraction. So like 0.25 is considered rational. But a decimal like pi is irrational. Anything that has a square root left in it is irrational. So like when we were solving by square roots, any of our answers that were left, like say we had plus or minus 5 square root of 2, that's irrational because it had a square root left in it. Repeating decimals like 0.454545 is considered rational. You can actually write those as a fraction. So any number that can be written as a fraction or as a whole number is considered rational. But it's not a perfect square. We still have two, but they're going to be irrational. Because if you are left with something, and we're going to get into a formula, and I'll kind of make a connection here. But if you do your discriminant and it's not a perfect square, that means that your x-intercepts are going to have a square. Z1, it's 1. Your vertex is sitting on the x-axis. And if it's negative, then we say that it has two imaginary. So imaginary. We're going to talk about imaginary numbers in our next lesson, but it really doesn't cross the x-axis. Those x-intercepts are imaginary. So we have 4 examples here. We're going to find the discriminant. So the discriminant itself is the number. The discriminant tells us how many x-intercepts and what kind of x-intercepts they are. So if we're looking at number 1, the discriminant, I'm going to do b squared, so 12 squared minus 4, a is 2, c is negative 13. We're just going to type that into the calculator. This 4 is just part of the formula. It's b squared minus 4ac. $248. If you're not sure, like if you get a bigger number and you're not sure if it's a perfect square, take the square root of that number and see if you get a whole number. Since I got a decimal, that means that 248 is not a perfect square. So my discriminant, if I say what is the discriminant, given the x-intercepts, it's positive, it's not a perfect square, we would say 2 irrational solutions, or x-intercepts, or roots, or zeros. Any questions? All right. Number 2, my discriminant. B squared, so 16 squared, minus 4. A is negative 1. C is negative 64. And I got 0, which means I have what? One rational. Number 3, my discriminant, 7 squared minus 4. My A is 20. My C is negative 3. I got 289. If you're not sure if that's a perfect square or not, let's see. Is it? Yep, it's a perfect square. So it's a positive number and it's a perfect square, 2 rational. And number 4, what is B?
3x2.
Nope.
24.
Nope.
0.
0. So your A is always the number with the x squared. Your B is always the number with the x. Your C is always the number by itself. Since I don't have a number with an x, my B is 0. So it's not, you can't just say it's always the second number. You got to be careful. So B is 0 squared minus 4. A is 3. C is 24. You get negative 288. It doesn't matter if 288 is a perfect square or not because it's negative. and negative has 2 imaginary. So, we have learned how to find x-intercepts by taking square roots. That method is preferred when you don't have a b term like this one. If I was telling you on number 4, if I was saying to find the x-intercepts, probably the easiest way to do that would be to do square roots. Add 24 or subtract 24, divide by 3, take the square root. Probably the easiest. Then we did factoring. Factoring is good when it works. Factoring does not always work. So the last method we're going to do is quadratic formula. Quadratic formula always works. You can use quadratic formula for any type of equation that you're given to find the x-intercepts. It looks a little more complicated. Sometimes it takes more time, but sometimes you have to use it on the examples where factoring doesn't work. Because sometimes, there aren't two numbers that multiply to be what you want them to and add to be what you want. That doesn't always work. So quadratic formula is the one that you can always go to. And here is that formula. X equals, it's a big fraction. It's negative b plus or minus. Plus or minus. I'll explain what that means. The square root of b squared minus 4. Does this look familiar?
No.
This part?
Just do that.
I just did it. A C.
Is that D or A?
That's an A. All over 2A. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So, told you, it's a little more complicated. It looks a little harder, but it does always work, and sometimes you have to use it. So, we did the discriminant right here. If this number is a perfect square, and you take the square root of a perfect square, it comes out as a whole number, which is why you'll end up with 2 rational solutions. If it's not a perfect square, then it's not going to come out as a whole number, which is why you have 2 irrational solutions. If it's 0, you only have 1. If it's negative, we've not talked about this yet, but you can't take the square root of a negative. So that's why there's 2 imaginary. We're not going to look at imaginary just yet. We're going to do ones where you get the other options. So we're going to work through these, and there's certain kind of steps I want you to follow. We're not going to just type the whole thing in the calculator and hit enter. Okay. We've got to do it step by step. So let's start out by just filling into the formula. So x equals... So your formula always has, hold on, what if I cover this up? Does that look familiar?
Yeah.
Negative b over 2a. We've done that to find the vertex, right? So that's kind of part of this quadratic formula. So negative b, you always have the negative, and then my b is 8. If your b was negative, you would put both negatives. Plus or minus, I'm not going to explain that yet. The square root b squared minus 4ac all over 2a. So the 2a is under the whole thing. So you have to be careful when you type it in. It does make a difference. The whole thing is a fraction. What the plus or minus means is that we basically have to figure this out once with the plus sign and once with the minus sign. And that's going to give us our two separate x-intercepts. Okay, but before we do that, I first want you to find just this value under the square root. So basically the first step I want you to do is find the discriminant. Don't type in the square root button just yet. Just the numbers underneath. $784. So I'm going to rewrite this, but I'm going to put a 784 there. And I can go ahead and do 2 times 5 and put a 10 on the bottom. That's okay. Is 784 a perfect square? No idea. So let's see. It is. So that's good. That means we're going to have nice whole numbers. It's going to be a little easier for us. So I'm going to replace that whole square root of 784 with a 28. So negative 8 plus or minus 28 over 10. If that was not a perfect square, I would have to split it up. I would have to simplify it. So that's why I need to check to see if it is. And so, no, we're not going to leave it yet because we can get answers for this. So we are going to do this once. We're going to type this fraction in. Once we're going to use a plus sign, and we're going to hit enter, and then we're also going to do it with a minus sign. There is no plus or minus in your calculator. So I'm going to go to alpha y equals negative 8 plus 28 over 10. And I get 2. And then negative 8, minus 28 over 10. And these are your x-intercepts. There's no setting anything equal to 0 or anything like that. If you are able to solve and get 2, like let's say you got a perfect square. If it's 2 rational solutions, that means this could have been done with factoring. Those numbers are kind of big. You probably would not have wanted to try to do that, but the box method would have worked here. But if you're like, I don't know, like you got to do 5 times 36, that might be a lot to try to think of those numbers and do the box method, so quadratic formula just works. So if I were to type in the 5x squared plus 8x minus 36 and look at the graph, it crosses the x-axis at 2 and about a little over negative 3. So let's go to number 6. So it's negative. What's my b? 1. 1. It's always the number. Don't put an x there. Plus or minus the square root 1 squared minus 4. What's a? 2. And c? negative 15. All over 2a, and a is 2. So we're just going to type in the discriminant part first to see kind of my next steps, to see if it's going to be a perfect square or not.
I said that. 121. What the heck?
I got 121. So is that a perfect square? Good. So this is really negative 1 plus or minus 11 over 4. So this parabola crosses the x-axis at negative 3 and at 2.5. You could have factored this one as well. But if you realize you hate the box method, now you can't really forget it, because there will be questions on the ACT that say to factor this, and you have to know how to do that, but you could always go to the quadratic formula.
And it'll be, is this any answer?
Do what?
This will be any answer?
If it's asking for the x-intercepts, the quadratic formula would always work. All right, number 7. Notice anything about number 7? It's not equal to 0. You have to get it equal to 0 first.
Minus 12.
Yep, so we'll subtract 12 from both sides.
And you were just subtracted from 19, huh?
Yes. That is something you have to watch out for, but that's the same thing on factoring. You have to have it equal to 0 to do factoring too. So I'm going to plug in.
Also a double negative. Oh, come on.
So I'm just filling in my A, B, and C. Let's go. And then we're going to type in what's underneath the square root. You got to be careful what mistake might some of you make here. Not putting the negative 9 in parentheses will mess you up. And I also went ahead and made this 9 positive, because a negative 9 is positive. If you leave it negative 9, that's okay too. But I got 25, which is a perfect square. Oops. I didn't fix that. 9 plus or minus 5 over 4. Because the square root of 25 is 5. 9 plus 5 over 4. And 9 minus 5 over 4. We have x-intercepts at 1 and 3.5, or 7/2. Number 8, we need to add 11x to both sides and subtract 33 from both sides. To get it set equal to 0. So 2x squared plus 5x minus 33 equals 0. I want you to finish it from here. Okay, you should have 3 and negative 11 over 2. Are there any questions? You're going to start seeing some that you do not get a perfect square when you do the square root part. Alright, so number 9. Let's fill into the formula. Negative b plus or minus the square root of b squared minus 4, a is 4, c is negative 1, all over 2a, 2 times 4. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And when I type in the discriminant part, I get 80. Is that a perfect square? No. So we have 2 irrational solutions. My answer is going to have a square root left in it. I'm not going to get a whole number or a fraction. What we do is we're going to go to the side and we're going to simplify the square root of 80. We want to break it down. We want to find the largest perfect square that goes into 80. So I'm going to do like 80 divided by 64. No. 80 divided by 49. Nope. 80 divided by 36. No. 80 divided by 25. No. 80 divided by 16. There we go. 16 times 5 is 80. So this is really the square root of 16 times the square root of 5. And what is the square root of 16? 4. So this is really 4 square root of 5. So this is negative 8 plus or minus 4 square root of 5 over 8. at this point, you might be done. We're not going to type this in the calculator. It's going to give us a weird decimal. It's not going to give us a nice decimal. That's the whole point of not even putting it in the calculator to begin with. But one thing you need to check is you need to look at these three numbers right there and see if there's anything that you can divide all three of those by. And that's going to simplify this fraction. You can divide them all by 4. So to simplify it completely, it becomes -2 plus or minus 1 square root of 5 over 2. And that's actually our final answer. This is where we stop. We're not going to split it up into 2. We're going to leave it just like this. Let's try number 10. Negative b plus or minus the square root b squared minus 4ac all over 2a. Get 56. Is 56 a perfect square? Nope. So we're going to go to the side and we're going to simplify the square root of 56. We want to find the largest perfect square that goes evenly into 56. Times 14. We have the square root of 4 and the square root of 14. The square root of 4 is 2. Left with square root of 14. We have -4 plus or minus 2 square root of 14 over 10. And we can divide all of these by 2 to get it more simplified.
Why did you leave 14 as it is?
Because that is a perfect square. The square root of 4 is 2. But 14, it's not a whole number. Square root of 14 is a decimal. You only numbers outside. You don't divide what's underneath. You only divide those 3. And those can all be divided by 2. We have to add 1 to both sides. Here's what I got. I ended up with the square root of 32, which simplified down to 4 square root of 2. And when I did simplify, I got a 1 in the denominator. If you leave it like that, that's okay. But if it was multiple choice, you would see it like the one I have boxed in. Because you don't write that as 5 over 4. That's implied.